Okay, 120 again. Please pause this. This is the bottom of page 10. Please pause this, copy this down, go. Okay, I'm back. This is a hand pump well. Basically, if you have a well in your house, same basic idea. Yours is probably not hand pump. It's probably an electric pump. You turn your faucet, you flush the toilet, turn on the shower. It automatically does this. You don't really see it. But deep down in the ground, there is a spot. This would be the water table, and it has to go below, and then this pumps it up. This is the old-time hand pump wells. And what I'm labeling is that this is the zone of saturation. So this is, the ground is saturated here. And this is the zone of aeration. And then this is the water table. Okay. I like that diagram. Here, I don't necessarily, there we go, that's better. This is off a little bit. But what I have labeled here, I would ask the question, what do I have labeled with the red line? And hopefully you would think that you would know that that is the water table in this spot. You can see here it zooms in of the actual individual soil particles, and it shows the water in between it, and your pump would suck the water out. Here, in this area here, it's dry, and there is some water in there. It clings to the sediment itself, but it's not really filling the spaces, so you can't really suck that water out. It's like the way water will cling to the inside of a water bottle or a glass a little bit. You can't really get that water out. It has to be in the zone of saturation for you to get a successful well. And this is what it looks like, basically. I like to point out that wherever you see a stream, it's usually where the ground intersects where the water table is. That's a cool thing to think about. I like that. So these 3D, this is a cross-sectional view. We cannot cut down through the earth 300 feet like this. This is a cross-sectional view. Remember that with the Snickers? Okay, this is actually a close-up here. This is the zone of saturation. Again, the water stored in between the grains. Here, the zone of aeration. There is water, but you can't suck it out. It clings to the sediments itself. Skip that. Springs up. I'll erase this. So this is a simple diagram. What it shows the water table here. And the water table often sort of conforms to the surface a bit. Maybe not here so much, but it does show that here's the water table. Now the land is down further here. Wherever the river surface is where it intersects the water table right there. And this is where if a river is flowing and it hasn't rained in a week, 2 weeks, 3 weeks, you don't have water runoff into the river. Where does that water come from? And the water comes from the ground into the river. It's called base flow. That's what provides the water, that the river that's just flowing without having any rain recently. Obviously, if it rains real hard and water rushes in, it's going to add more water. The level of the river will rise for that day, next day, 2 days, as it deals with all that runoff from maybe a heavy rainfall. Whoa. That's a crazy drawing that I did. It made a lot of sense at the time. That's also a crazy drawing. Holy cow. Another one. I like this picture right here, if you can see this picture right here. I don't think you have this in your notes. As a matter of fact, I know that you don't have it in your notes. But it does show that if you're really pumping a well here, what you get is this, you pump hard, the water moves sideways real slowly here. It moves very slowly. You pump hard, you can get this sort of like, the water goes down here as it's like sucking water up. And then if you stop pumping, it will flatten out. It's called the cone of depression. It's just a cool thing, really good cross-sectional view, especially right here. So I'm going to stop this episode right here.